Sewage treatment facility operation and management. This lecture will allow you to increase your professional knowledge of wastewater treatment operation by learning about operational methods for sewage treatment plants. I will present an overview of sewage treatment facilities and discuss sewage treatment facility operation and management in order. Overview of sewage treatment facilities. From the past until today, the major wastewater treatment plants in South Korea have used a standard activated sludge method, and based on this method, A2O, advanced treatment methods have been developed. Generalized processes in wastewater treatment plants are as follows. First, relatively heavy particles like sand and earth are removed by an inflow pump and grit chamber, and organic material and suspended solids are removed in a primary sedimentation tank. Microbes and organic material are consumed and disintegrated in a bioreactor, and the microbes which consume organic material are settled, after which the upper layer of clear water is discharged into a secondary sedimentation chamber. The amount of sludge produced by primary and secondary sedimentation is reduced in a sludge thickener. Then the thickened sludge is digested and gas is produced. Finally, the liquid sludge is conveyed from the sludge thickener or dewatering to produce solid sludge. Please note that the sludge cake produced is disposed of outside the plant through incineration or solidification. These sewage treatment facilities require plant operational management. So far, wastewater treatment facilities in Korea have been repaired and improved when damaged. However, plant operational management of facilities is required to maintain facility functionality, and preventative operational maintenance is very important for extending facility lifespan. Finally, planned preventative operational management contributes to extending facility lifespan and decreasing total operation and management expenses. As you can see on the graph, plant maintenance before facility functionality decreases, or there is a malfunction, is more effective for extending facility lifespan and maintaining high facility functionality than maintenance work after facility functionality decreases, or there is a malfunction. Sewage treatment facility operation and management. Next, I'll talk about overall operational management for the plant, preventative management of sewage treatment plants. The following operational management factors should be considered in order to increase the operational efficiency of wastewater treatment plants. The grit chamber removes soil, sand, and various debris, which is taken in with the inflow water to prevent later damage to facilities used in the sewage treatment process. First, methods must be prepared for preventing settling of organic matter in the grit chamber and operating screen equipment and spinning equipment. In the screen facility for debris removal, as a precaution during rainy weather, operational methods must be prepared and followed for removal and external disposal of debris when screening. You should also check to make sure that the level gauge in the grit chamber, which prevents flooding, is working, and to make sure that the sluice gate doesn't stick to the frame. The grit facilities should be regularly painted as a measure against flooding and exposure to corrosive gases, and after investigating the volume of grit by season, an interval for grit removal should be selected, and removal needs to be carried out according to this interval to prevent the accumulation of grit during the rainy season. From the grit chamber, treated wastewater is moved to the primary sedimentation basin by an inflow pump. In the inflow pumping facility, the level should be monitored by time of day for speed control, following increased volumes of wastewater intake, or appropriate operation of pumps with 2 or more different capacities. Periodic maintenance checks should be conducted on the pump structure, etc., and operation methods should be prepared for changes in wastewater volume by time of day or season. It is necessary to evaluate standards to make sure that the starting frequency of the intake pump, when in operation, is 6 times per hour or less, and to prevent water shock during operation. Another necessary part of operation when carrying out level control is to check that the water level switch system is operating normally, continue monitoring for unusual sound or vibration, and check the grounding and insulation resistance of the electric motor. In flow adjustment tank facilities, the operational management of the agitator and discharge device are important. First, appropriate mixing and oxygen supply are required to prevent sludge sedimentation and decomposition. And oxygen injection with a DO of around 0.5 mg per liter should be maintained to prevent decomposition in wastewater. For the discharge device, speed control or control of the opening and closing of the discharge valve should be carried out so that appropriate amounts of wastewater inflow and outflow are maintained. Daily average inflow and outflow quantities at the wastewater treatment plant should be calculated, and the level should be set slightly higher than this level. One important item that the seasonal, daily, and hourly levels of wastewater volume should be calculated for other flow adjustment tank facilities to manage daily inflow volume patterns. In the primary sedimentation tank, sedimentation is carried out over 2 to 3 hours to remove suspended solids and precipitants and lower the pollution load in the raw water reactor. Sedimentation that falls to the floor is moved to a treatment process. In the primary sedimentation tank, the scum removal equipment, wastewater, debris collector, pump, and automatic control device should be checked for normal operation, and the sedimentation time needs to be adjusted with consideration for the operational management of the secondary sedimentation tank and biological reactor. The sludge interface should be continually monitored, including checks for normal operation of the raw sewage pump, sludge, which adheres to a weir, to achieve uniform weirs, algae, periodic cleaning of contaminants, regular checks of the weir level to prevent damage to the weir surface or imbalance, and measurement of the sludge interface at least twice per week to achieve the target concentration of drain sludge. In addition, an operation method must be decided on based on the structure of the sewage waste collector, control method, and the amount of sludge produced. Also, it is necessary to prepare methods for checking the condition of the sewage waste collector, such as checking for chain loosening or wear due to the continuous operation of the collector, the limit switch, the electric motor, heat production in the bearings of the reducer, rotational status, lubrication status, vibration, and abnormal noises. It is important to check the operational status of the scum removal device and for removal of scum. In the bioreactor facilities, instructions for the management of the reactor should be prepared, such as aeration time, adjustments to airflow rate, and adjustments for return or excess sewage. Items like residence time, BOD, and SS load, SRT, and MLSS concentration should be considered for optimized operational conditions, and there need to be countermeasures for activated sludge, bulking, and flotation. Also, the pressure gauge, thermometer, ammeter, and so on of the air diffuser should be periodically checked for normal operation, and there should be detailed checks of the oxidation efficiency of the air diffuser, such as the method for adjusting airflow to ensure sufficient DO and checking aeration size. In addition, it is important to measure SV, SVI, DO, the BOD of the bioreactor, SS, and so on, to establish a method for operational management. Check for control of the amount of airflow and return sewage residue in proportion with DO and MLSS. When operating the air diffuser, use a reducer method to keep excessive starting current from flowing. Perform regular maintenance checks on the DO and MLSS gauges and check for the normal operation of antifoaming equipment. In addition, the antifoaming water nozzle can be easily clogged, so it should be regularly checked and cleaned, and the overcurrent protection set point of the air diffuser's electric motor should also be checked. In secondary sedimentation facilities, the weirs should be cleaned to keep foreign matter from adhering to them, and the weir surface should be checked for damage and sludge overflow. The draw status of the automatic control system of the returned wastewater sludge pump should be checked. Operational management measures should also be prepared, such as sedimentation time and wastewater sludge draw rate, and SV adjustment for reactors. Measures should be prepared for regular calibration and checks of the wastewater sludge concentration meter, and appropriate operation of the draw valve and pump for drawing wastewater sludge. In addition, operational methods must be decided on in consideration of the structure of the sewage collector, control method, and the amount of sludge produced. It also is necessary to prepare a method for checking the sewage collector, such as checking for chain loosening or wear due to the continuous operation of the collector, and checking the limit switch, electric motor, reduction of heat in the ball bearings of the reducer, rotational status, and abnormal noise. The sludge interface should be checked at least twice per week and continually managed in order to achieve target MLSS concentration. In disinfection facilities, first staff must be familiar with items like the precautions, properties, temperature, and storage method of the chemical used when handling a chemical for disinfection, and there should be a check for secondary contamination from chlorine compounds. In particular, because chlorine is extremely toxic, sufficient care must be taken when handling it. Be mindful of the fact that if the chlorine compound is stored for a long time, the amount of effective oxygen in it decreases. It is necessary to prepare measures for responding to accidents like chlorine gas leaks and to remain aware of these measures. In addition, you must install ventilation equipment in indoor spaces where ozone reactor facilities are installed, and install an ozone detector to monitor ozone levels and give a warning if ozone levels reach 0.1 ppm or higher. For UV disinfection, you must check regularly that the light is on in order to increase disinfecting power. And if it is discovered that the lamp is not on, measures like early replacement of the lamp should be taken. It is also necessary to periodically check for contamination or scaling in guard pipes and to clean them if necessary. For automatic water quality measurement facilities, it is necessary to distinguish between daily, monthly, quarterly, and overall inspections. Daily checks include checking the operational status and data transmission of water gauges, cleaning the sample collection basin, electrode cleaning, and checking the automatic sample collector. As a monthly check, the zero/span is adjusted and compared with a numerical analysis to ensure the performance of the gauge. As a quarterly check, the performance of the gauge needs to be evaluated with respect to precision, repeatability, and reproducibility, and adjusted, and it should be managed with a conversion formula to allow for comparison of the concentration of pollutants in the water. Finally, as an overall check, it is necessary that the gauge be disassembled and cleaned, the parts be repaired or replaced, and the reproducibility of performance be checked in order to improve the operational efficiency of the automatic water quality measurement facilities. In water quality laboratory facilities, staff should be familiar with items like the overview and goals of water quality management, water test equipment specifications, and handling instructions, test categories, frequency, categories and standards for water quality management, sample collection methods, location, and sample amount, and should handle them in connection with overall water quality management instructions. Finally, there is the management of safety and environmental protection. For safety and hygiene management, you need to be aware general safety management guidelines, instructions for handling hazardous materials, such as high-pressure chlorine gas, measures for hygiene management, discharge water quality standards for environmental protection, odor, noise and vibration, instructions for the management of waste, and the requirements of relevant legislation. In addition, you need to be familiar with the command system and measures to take in the event of a power outage or accident due to a natural disaster. I've talked to you about general factors for wastewater treatment. and the operational management of wastewater treatment facilities. I hope you found it helpful, and I hope you'll continue to pay attention to this area so that you can achieve planned, efficient operation of wastewater treatment plants in your own countries. Thank you.